Sri Gurubhyo Namaha children. Welcome to our online teaching academy, Ekalaiva. Exercise 8.1, 9th question in the chapter Quadrilaterals. In parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to BQ. Show that triangle APD is congruent to triangle CQB. AP is equal to CQ. Triangle AQB is congruent to triangle CPD. AQ is equal to CP. APCQ is a parallelogram. So what is given? Triangle parallelogram ABCD is given, right? So parallelogram ABCD is given. Parallelogram ABCD is given, and P and Q are points taken on diagonal BD such that DP and BQ are equal. Okay, so parallelogram ABCD is given, and 2 points P and Q are taken on diagonal BD such that DP is equal to BQ. You have to prove the following things. Okay, so you know in a parallelogram opposite sides will be parallel and equal. Also, when two sides are parallel and if it is cut by a transversal, alternate interior angles are equal. So to prove the first one, so before that we have to write what is given in the question. So what is given in the question? ABCD is a parallelogram. What is given? ABCD is a parallelogram. And points P and Q are taken on the diagonal BD such that DP is equal to BQ. It is also given DP and BQ are equal. And you have to prove the following things. Whatever is given. What is to be proved? The first one is triangle APD is congruent to triangle CQB. The second one is you have to prove AP is equal to CQ. And the third one is triangle AQB is congruent to triangle CPD. And the fourth one is AQ is equal to CP. And the fifth one is APCQ is a parallelogram. Okay, so what is given? ABCD is a parallelogram and DP is equal to BQ. So we have to prove all this. So to prove this, before that we have to discuss about the parallelogram. In a parallelogram, you know, opposite sides are parallel as well as equal. That is, ABCD is a parallelogram where AD and BC are parallel and equal. Similarly, AB and DC are parallel and equal. That is, AD and BC are equal and parallel. Similarly, AB and DC will be parallel and equal. Also, BD acts as a transversal. This alternate interior angles will be equal. That is, angle ADB will be equal to angle DBC. Okay. So using that, we are going to prove the first one. That is, in triangle APD, whichever triangles have to be proved congruent, that we have to take. So in triangle APD and triangle CQB. So let me show those two triangles separately, right? A, P, D and B, Q, C. You know, in a parallelogram, opposite sides are equal. So AD and BC are equal. And they have given in the question, that is DP and BQ are equal. Okay, so two sides are equal in both the triangles. And as I discussed now, AD and BC are parallel and BD acts as a transversal. So alternate interior angles are equal. That is, here the points are given as P and Q here. So angle ADP is equal to angle QBC. That is, angle ADP is equal to angle QBC. They are nothing but the alternate interior angles. Since AD and BC are parallel and BD acts as a transversal, angle ADP is equal to angle QBC. Okay, so let us write what all is given equal. So AD is equal to BC. The reason is opposite sides of a parallelogram. Opposite sides of a parallelogram are always equal. And DP is equal to BQ. That is given in the question itself. DP is equal to BQ given in the okay, DP is equal to BQ given. Okay, and one more angle we discussed. What is the angle? That is angle ADP is equal to angle QBC. Angle ADP is equal to angle QBC. They are nothing but what type of angles? They are alternate interior angles. They are alternate interior angles. So in these two triangles, two sides are equal and the included angle is equal. So we talked about two sides which are equal and the included angle. So what congruence they form? SAS congruence. So by SAS congruence, triangle APD is congruent to triangle CQB. So triangle APD is congruent to triangle CQB. Now when I say two triangles are congruent, not only the two sides and the included angle which we discussed now will not be equal, the other one side, that is the third side, as well as the other two angles will also be equal by CPCD. What is CPCD? Corresponding parts of congruent triangles. Since they are congruent triangles, the third side will also be equal by CPCD. So the second proof will also gets over. That is AP is equal to CQ by CPCD. Since triangle APD is congruent to triangle CQB, we can say AP is equal to CQ by CPCD. Okay. Now let us see the third proof. So for the third proof, which triangles we need? AQB and CPD. So AQB and CPD. Here again, when you look at the triangle AQB and CPD, AB and DC are parallel to each other. AD and BC are parallel to each other and BD acts as a transversal. Here again, the alternate interior angles are equal. So let us discuss that now. So ABCD is a parallelogram, right? ABCD is a parallelogram and BD acts as a transversal, and there is a point here Q and there is a point P over here, and here again AB and DC are parallel and BD acts as a transversal. So these alternate interior angles are equal. What is that? Angle ABQ is equal to angle PDC. Angle ABQ is equal to angle PDC. So using that, we are going to prove the third one. What is the third proof? Triangle AQB should be proved congruent to triangle CPD. So in triangle AQB and triangle CPD, okay, we can say the alternate interior angles are equal, right? So let us take those two triangles. What are the triangles? AQB and AQB and CPD. Okay. Here you know angle ABQ is equal to angle PDC, alternate interior angles. AB and DC are equal, they are opposite sides of the parallelogram and they are given in the question itself. DP and BQ are equal. DP and BQ are equal. So here we write AB is equal to DC. The reason is again opposite sides of a parallelogram are always equal. So opposite sides of the parallelogram. So AB and DC are equal. Then we know BQ is equal to, that is BQ is equal to DP, that is given in the question itself, right? And the alternate interior angles, what are they? Angle ABQ is equal to angle PDC. Reason is alternate interior angles. Alternate interior angles are always equal. Alternate interior angles are always equal. When two parallel lines are cut by a transversal, alternate interior angles are always equal. So here again, two sides of the triangle of both the triangles are equal and the alternate interior angles are equal. That is, the included angle is equal. So two sides and the included angle is equal in both the triangles. So by SAS congruence, these two triangles are congruent. That is, triangle AQB is congruent to triangle CPD. Okay. So since those two triangles are congruent, again the third set will be equal by CPCD. So AQ will be equal to PC by CPCD. So AQ is equal to CP by CPCT. So the fourth proof also got over. What is the fourth proof? AQ is equal to CP. That also we proved that is equal. Now what is the fifth one? We have to prove APCQ is a parallelogram. We have to prove APCQ is a parallelogram. So let us see how to prove APCQ is a parallelogram. You know, in any quadrilateral, if both the pairs of opposite sides are equal, then it is a parallelogram. Now, in quadrilateral, what quadrilateral? APCQ, in quadrilateral APCQ, both the pairs of opposite sides are equal. That is, if I take that APCQ, if I take that quadrilateral, just now in the second proof we proved AP is equal to CQ, and in the fourth proof we proved AQ is equal to CP. That is, both the pairs of opposite sides are equal. So in any quadrilateral, if both the pairs of opposite sides are equal, then it becomes a parallelogram. So in quadrilateral APCQ, AP is equal to CQ and AQ is equal to CP. These were not given, we proved it. So both the pairs of opposite sides are equal, which implies APCQ is a parallelogram. Okay. So in any quadrilateral, if both the pairs of opposite sides are equal, then it becomes a parallelogram. So we have proved all the 5 proofs which are told to be proved. Is it clear, children? Hope it's clear. Now let us see the next question, 10th question. ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on diagonal BD. You have to show that triangle APB is congruent to triangle CQD and AP is equal to CQ. So what is given? ABCD is a parallelogram. ABCD is a parallelogram and AP and CQ are the perpendiculars from the vertices A and C on the diagonal BD, and you have to prove 2 things. Okay, so what is given in the question? That should be written first. So what is given? ABCD is a parallelogram. What is given? ABCD is a parallelogram. And AP and CQ are perpendiculars drawn from the vertices A and C on BD, which means AP is perpendicular to BD and CQ is also perpendicular to BD. Right? So what are you supposed to prove? They have given you 2 things to be proved. What are they? To prove triangle APB is congruent to triangle CQD. And what is the second one? We have to prove AP is equal to CQ. Okay. So here again, let us apply the parallel lines and transversal property. That is, ABCD is a parallelogram. ABCD is a parallelogram. Right? ABCD is a parallelogram, right? ABCD is a parallelogram. BD acts as a transversal. Okay, you know, in a parallelogram, opposite sides are parallel. So AB and DC are parallel, and BD acts as a transversal. So alternate interior angles are equal. That is, here there is a P and here there is a Q. So angle ABQ and angle CDP are equal, right? Angle, okay, angle, this is 90 degree and this is also 90 degree, right? So AB and DC are parallel and BD acts as a transversal, alternate interior angles are equal. What are they? Angle CDQ and angle ABP are equal. Okay, so using that we are going to prove the first one. So which triangles have to be proved congruent? APB and CQD. So let us take those 2 triangles, APB, and another one is CQ and D. CQD, not CQ and D, it is CQD. Okay, CQD. You know, in a parallelogram, opposite sides are equal. So AB and DC are opposite sides of the parallelogram, so they are equal. And they have given AP is perpendicular and AP and CQ are perpendiculars drawn. So angle APB is 90 degree and angle CQD is also 90 degree. And just now I said AB and DC are parallel and BD acts as a transversal. Angle CDQ, this angle is equal to angle APB. That is nothing but alternate interior angles. Two parallel lines cut by a transversal, alternate interior angles are equal. So two angles are equal and one of the side is equal. So three elements are equal in both the triangles. So we can prove them to be congruent. So let us see how it is done. Okay. The first one is which two triangles have to be proved congruent? Triangle APB and triangle CQD. In these two triangles, AB and DC are equal because they are opposite sides of the parallelogram. AB equal to DC, opposite sides of the parallelogram. Opposite sides of the parallelogram are always equal. And I have given AP and CQ are perpendiculars. So angle APB is equal to angle CQD. Okay. So both are equal to 90 degree. It is given. Right. It is given in the question itself. They are perpendiculars. And angle ABP is equal to angle CDQ. Angle ABP and angle CDQ. They are equal because they are alternate interior angles. Alternate interior angles. Alternate interior angles. Now here two angles are equal and one of the side, it is not an included side because both the angles are not lying on the equal side. Only one angle is lying on it. So two angles are equal in both the triangles and one of the side is equal. So by what congruence? By AAS congruence. These two triangles are congruent. By AAS congruence, these two triangles are congruent. Which two triangles are congruent? APB and CQD are congruent. Triangle APB is congruent to triangle CQD. Triangle CQD. And what is the next one? You have to prove AP is equal to CQ. You know, in any two triangles are congruent, not only one side will be equal, the other two sides will also be equal by CPCT. So AP will be equal to CQ by CPCT. What is CPCT? CPCT is nothing but corresponding parts of congruent triangles. Since triangle APB and triangle CQD are congruent, AP is equal to CQ by CPCT. So hence we have proved the 10th question also, okay, using congruence. Now let us see the 11th question. In triangle ABC and triangle DEF, AB and D. So there are two triangles ABC and DEF. In that AB is equal to DE and AB is parallel to DE. AB and DE are equal as well as parallel. So in triangle ABC and triangle DEF, AB and DE are equal and parallel. And also BC and EF are equal and BC and EF are also parallel. So BC and EF are equal as well as parallel. And vertices A, B, C are joined to vertices D, E and F respectively. That is A is joined to D, B is joined to E and C is joined to F respectively. And you have to show that. That is, you have to prove 6 things has been given to be proved. So what is given in the question? That you have to write first. So what is given in the question? AB is equal to DE and AB is parallel to DE. Also BC equal to EF and BC is parallel to EF. Okay. And you have to prove so many things. What are all given? You have to prove first one, quadrilateral ABED is a parallelogram. The second one, quadrilateral DEFC is a parallelogram. Third one, AD is parallel to CF and AD is equal to CF. Fourth one, quadrilateral ACFD is a parallelogram. Fifth one, AC equal to DF. And the sixth one is triangle ABC is congruent to triangle DEF. Okay. So we have to prove first thing ABED is a parallelogram. ABED is a parallelogram. So let us see how to prove the first one. Okay. So it is given AB and DE are equal and parallel. So when I take the quadrilateral ABED, when I take the quadrilateral ABED, AB is equal to DE and AB is parallel to DE. So AB and DE are parallel and equal. In any quadrilateral, if one set of opposite side is parallel and equal, then it becomes a parallelogram. So the first proof is in quadrilateral ABED, AB is equal to DE and AB is parallel to DE. This is given in the question itself, right? So when one set of opposite side is parallel and equal, it becomes a parallelogram. Therefore, ABED is a parallelogram. Okay. Since one set of opposite side is parallel and equal in a quadrilateral, it is a parallelogram. Let us see the second proof, that is BEFC. So let us see how to prove the second one, BEFC, right? So how to prove the second one, BEFC. So BEFC, let us take that quadrilateral BEFC. Okay, BEFC. So here BC and EF are given equal as well as BC and EF are given parallel. So in quadrilateral BEFC, BC and EF are parallel and equal. It is given in the question itself. In any quadrilateral, again, if one set of opposite set is parallel and equal, it becomes a parallelogram. So in quadrilateral BEFC, BC equal to EF and BC is parallel to EF. That is given in the question itself. Since one set of opposite side is parallel and equal, it becomes a parallelogram. So BEFC is a parallelogram. Okay. So when I say it is a parallelogram, not only one set of opposite side will be parallel and equal, the other set of opposite side will also be parallel and equal. So when I say ABED is a parallelogram, okay, since ABED is a parallelogram, not only AB and DE will be parallel and equal, AD and BE will also be equal. So AD is equal to BE and AD is parallel to BE. Also, since BEFC is a parallelogram, which we have proved just now, not only BC and EF will be parallel and equal, BE and CF will also be parallel and equal. So BE is equal to CF and BE is parallel to CF. Now, I'll mark this as equation number 1 and 2. You can see AD is equal to BE in the first equation and that BE is equal to CF. So AD is equal to BE and BE equal to CF, which means AD and CF are equal. Similarly, AD is parallel to BE and that BE is parallel to CF, which means AD, BE and CF, all the three are parallel to each other. So from the first and second equation, we can say AD is equal to BE and that BE is equal to CF, which implies, okay, so from 1 and 2, I can say AD is equal to BE and that BE equal to CF. So I can say AD equal to CF. Similarly, AD is parallel to BE and BE is parallel to CF. So AD and CF will be parallel. So from 1 and 2, I can say AD equal to CF and AD is parallel to CF. That is what is the third proof. That is AD is equal to CF and AD is parallel to CF. That we have proved. And we have to prove the fourth one, quadrilateral ACFD is a parallelogram. Quadrilateral ACFD is a parallelogram. Just now we proved AD and CF are parallel and equal, so it becomes a parallelogram again. Okay, ACFD. We have to prove ACFD is a parallelogram. Okay, so let us take that ACFD. A, C, F, D. Just now we proved AD and CF are equal and AD and CF are parallel. Again, in any quadrilateral, if one set of opposite sides is parallel and equal, it becomes a parallelogram. So in quadrilateral, ACFD, AD is equal to CF and AD is parallel to CF. This is not given in the question, we have just proved it. Okay, so AD and CF are parallel and equal. Therefore, ACFD is a parallelogram because in any quadrilateral, if one set of opposite sides is parallel and one set of opposite sides are parallel and equal, then it becomes a parallelogram. Again, in any parallelogram, not only one set of opposite sides will be parallel and equal, the other set of opposite side will also be parallel and equal. So I can say AC is equal to DF because opposite sides of a parallelogram are always equal. So opposite sides of a parallelogram are equal. So AC equal to DF. Now the last one is we have to prove triangle ABC is congruent to triangle DEF. Triangle ABC has to be proved congruent to triangle DEF. Okay. In the question itself, they have given AB and D are equal and also B is given equal to EF. AB is equal to DE and BC equal to EF is given in the question itself. And just now we proved AC and DF are equal. So in both the triangles, three sides of both the triangles are equal. So by SSS congruence, they become congruent. So let us take those two triangles. What triangles? ABC and DEF. So in triangle ABC and triangle DEF, AB is equal to DE and BC equal to EF. These two are given in the question itself. And the third one, that is AC equal to DF, has been proved by us just now. So AC is equal to DF. We have just now proved. So three sides of both the triangles are equal. So by SSS congruence, these two triangles are congruent. Which two triangles? Triangle ABC is congruent to triangle DEF. Yes. So let us move on to the next question. Question number 12. Okay. So what is given? ABCD is a trapezium in which AB is parallel to CD and DE is equal to BC. We have to show that angle A is equal to angle B, angle C equal to angle D, and triangle ABC is congruent to triangle BAD, and diagonal AC equal to diagonal BD. So what is given? ABCD is a trapezium. You know, in a trapezium, always one set of opposite side will be parallel. So AB is parallel to DC, that is given. So ABCD is a trapezium in which AB and CD are parallel and AD is equal to BC. These two are given equal. You know, in a trapezium, one set of in a trapezium, one set of opposite side will be always parallel, and if the non-parallel sides are equal, then it becomes an isosceles trapezium. So ABCD is an isosceles trapezium. So we have to prove so many things. So let us see how it should be proved. The first one given, what is given? ABCD is a trapezium. ABCD is a trapezium in which AB is parallel to CD, sorry. ABCD is a trapezium in which AB and CD are parallel and AD is equal to BC. This is given. And what are supposed to prove? We have to prove, first one, angle A is equal to angle B. The second one, angle C is equal to angle D. Third one, triangle ABC is congruent to triangle BAD. The fourth one, diagonal AC is equal to diagonal BD. Diagonal AC is equal to diagonal BD. Okay, so to prove this, what we do is we extend this AB and we draw a line through C parallel to AD. That is, this line CE is drawn through E parallel to AD and it meets the extension of AB at E. Okay, so ABCD is a trapezium and a line through E, that is CE, is drawn parallel to DA and it meets the extension of AB. When we extend the AB, it meets at the point E. So this is the point E where the extension of AB and the line CE intersect each other. Okay, and it's given CE is parallel to DA. Okay, so that is given as a hint, that is extend AB and draw a line through C parallel to DA intersecting AB produced at E. Okay, so AD and CE are parallel. Okay, now we have to prove this, so many things. So let us see how it should be proved. Now, you know AB and DC are parallel, which means AE and DC will also be parallel. Okay, since AB is parallel to CD, the extension of AB, that is AE, will also be parallel to CD. Okay, also DA is parallel to CE. This is given or hint. Okay, given in the hint, right? So AB, that is quadrilateral. I take the quadrilateral ADCE. Okay, there is a B here. Okay, AB is parallel to DC, so AE is parallel to DC. Also, DA is parallel to CE. That is, two sets of opposites are parallel in this quadrilateral. So it becomes a parallelogram. In any quadrilateral, if both the pairs of opposites are parallel, then it becomes a parallelogram. So which implies ADCE is a parallelogram. Okay. How did we prove? AB is parallel to DC, so AE is parallel to DC, and DA is parallel to CE. It is given in the hint. That is, CE is drawn parallel to DA. So two sets of opposite sides are parallel. So in any quadrilateral, if both the pairs of opposite sides are parallel, then it becomes a parallelogram. Therefore, ADCE becomes a parallelogram. So in a parallelogram, opposite angles will be equal and sum of the adjacent angle will be 180. That is, angle DAB plus angle CEB will be equal to 180. Angle DAB plus angle CEB will be equal to 180 because sum of the adjacent angle is always 180 in a parallelogram. Okay, so angle DAB plus angle CEB is equal to 180. Sum of the adjacent angles in a parallelogram is always 180. Sum of the adjacent angles in a parallelogram is always 180. Okay. Now, since it is a parallelogram, not only the opposite sides will be parallel, both the pairs, it will also be equal. So, AD is equal to CE. Opposite sides of a parallelogram are always equal. Opposite sides of a parallelogram are always equal, right? But it's given in the question AD is equal to BC. It is given in the question that AD is equal to BC. So AD is equal to BC, it is given. Therefore, BC and CE are equal. AD is equal to C and AD equal to BC, which means BC and CE are equal. BC and CE are equal. Let me take the triangle BCE. Let me take the triangle BCE. Now BC and CE are equal. In any triangle, when two sides are equal, then the angle opposite to them will also be equal. Then the angle opposite them will also be equal. Okay. In triangle BCE, BC equal to CE, the angle opposite to BC is BEC, that is equal to angle opposite to CE is CBE. Angles opposite equal sides are equal. Angles opposite to equal sides of a triangle are equal. Okay, so BEC is equal to CBE. And when you look at it, you know angle CBE plus angle ABC makes 180 because they are linear pair of angles. Angle CBE and angle ABC, they form 180 degree because they are linear pair of angles. Angle ABC plus angle CBE is equal to 180. Angle ABC plus angle CBE is equal to 180 because it is linear pair of angles or straight angle. Okay. I'll mark this as equation number 1 and this as equation number 2. Let me mark this as equation number 1. I mark it clearly. Let me mark this as equation number 1 and this as equation number 2. From 1 and 2, since the right side is equal, the left side will also be equal. So from 1 and 2, I can say angle DAB plus angle CEB is equal to angle ABC plus angle CBE. Okay, but you know CEB and CBE are equal, but you know CEB and CBE are equal. So I replace the CEB with CBE. So DAB plus CBE is equal to ABC plus CBE. Because I know BEC is equal to CBE. BEC is equal to CBE. So BEC I replace with CBE. So now CBE, CBE on either side get cancelled. So angle DAB is equal to angle ABC. That is angle DAB is equal to angle ABC. We prove angle DAB is equal to angle, these two angles. Angle DAB is equal to angle ABC. That is nothing but angle A and B for the trapezium. So that is angle A is equal to angle B. Okay. So we have proved the first one, that is angle A is equal to angle B. Okay. What is the second one we are supposed to prove? Angle C is equal to angle D. You know ABCD is a trapezium. You know ABCD is a trapezium. Okay. Where AB and DC are parallel. Okay. So when two parallel lines are cut by a transversal, you know sum of the co-interior angles on the same side of transversal is 180. So AB and DC are parallel and AD acts as a transversal. Angle BAD plus angle ADC is equal to 180. Similarly, when AB and DC are parallel and BC acts as a transversal, angle ABC plus angle BCD will be 180. Again, sum of the co-interior angles on the same side of transversal is 180. Okay, so let us do that. Okay, since AB is parallel to DC and AD acts as a transversal, I can say angle BAD plus angle ADC is equal to 180. Similarly, again I say since AB is parallel to DC and BC acts as a transversal, I can say angle ABC plus angle BCD is equal to 180 degree. Okay, because sum of the co-interior angles on the same side of transversal is 180. Sum of co-interior angles on the same side of transversal is 180. Okay, that is the reason for the fourth equation also. Now look at the third and fourth equation. The right side is equal, so the left side will also be equal. So from 3 and 4, I can say angle BAD plus angle ADC is equal to angle ABC plus angle BCD. And just now we proved angle DAB and angle ABC are equal. That is angle DAB and angle ABC are equal. So I cancel them on either side. So I get ADC is equal to BCD. So I get angle ADC equal to angle BCD. That is angle ADC is equal to angle BCD. They are nothing but angle C and D of the trapezium. That is angle C is equal to angle D. That is angle C is equal to angle D. That is angle D is equal to angle C. So the second proof is also over. What is the third proof? We have to prove triangle BAD is congruent to triangle ABC. Triangle ABC and triangle BAD are have to be proved congruent. So triangle ABC and triangle BAD have to be proved congruent. Here you know AB is common in both the triangles and it is given in the question itself AD and BC are equal, and just now we have proved angle BAD and angle ABC are equal. So two sides and the included angle of both the triangles are equal, so they are congruent by SAS congruence. So let us take that in triangle ABC and triangle BAD, I know AB is common in both the triangles, right? In triangle ABC and triangle BAD, which is common, AB is common. Side AB is common in both the triangles. So AB is common and AD is equal to BC. It is given in the question itself. And just now we proved in the first proof, angle BAD, that is for the triangle ABC, it is ABC. For the triangle ABC, it is ABC. So ABC is equal to, angle ABC is equal to angle BAD. This we have proved just now. Okay. So in triangle ABC and triangle BAD, AB is common and AD and BC are given equal, and angle ABC is equal to angle BAD, that has been proved. So two sides and included angle of both the triangles are equal. So by SAS congruence, these two triangles are proved to be congruent. That is triangle ABC is congruent to triangle BAD. Triangle ABC is proved to be congruent equal to triangle BAD. BC and AD are given equal, right? So these two triangles are congruent by SAS congruence. So in congruent triangles, not only there, two sides will be equal, the third side will also be equal by CPCT. So diagonal AC will be equal to, diagonal AC will be equal to diagonal BD. That is, this diagonal AC and diagonal BD will be equal by CPCT because they are corresponding parts of the congruent triangles. Hope it's clear, children. To receive our online lessons, please click the subscribe button to get the latest updates. Thank you.